everyone. Today we are going to solve ATP paper of Feb March 2023. Long chain alkanes can be broken down into shorter chain alkanes and gaseous alkenes. Vapor from a long chain alkane is passed over a very hot catalyst and gases formed are collected over water. The apparatus used is shown in the figure. Here we can see that in the test tube, delivery tube is attached and here the gases are collected. Name the term of apparatus labeled A. So this is known as a water bath or also known as a trough. The catalyst is small pieces of aluminium oxide. Explain why several small pieces of aluminium oxide speed up the reaction more than one large piece of aluminium oxide. So when there are small pieces of aluminium oxide, it will increase the surface area and help in the increase in rate of reaction or speed of reaction. Name the item of apparatus that can be used to heat the long chain alkane and catalyst. So we are going to use a Bunsen burner to heat the reaction. Add two arrows to figure 1.1 to show where the apparatus should be heated. So it should be heated here where long chain alkenes on mineral wool is there, and the second where we are going to heat it is here where our catalyst is present. The gas collected is tested using aqueous bromine. Alkenes turn aqueous bromine from orange to colorless. When the first few bubbles of gas collected are tested, the aqueous bromine does not change color. Explain why the aqueous bromine does not change color. So the first few bubbles which come out is the air which was present in the delivery tube. As soon as the experiment is over and heating is stopped, the delivery tube must be removed from the water. Explain what happens if the delivery tube is not removed from the water as soon as the heating is stopped. So the water will move back into the test tube and the test tube may break. A student investigates the solubility of ammonium chloride in water at different temperatures. The student does the 5 experiments using the following instructions. So experiment 1, fill a burette with distilled water. Run some of the water out of the burette so that the level of the water is on the burette scale. Use the burette to add 8.0 centimeter cube of distilled water to a 5.25 gram sample of ammonium chloride in a boiling tube. Clamp the boiling tube at an angle as shown in the figure. Gently heat the bottom of the boiling tube while stirring the contents with a thermometer. Stop heating as soon as the solid has dissolved. Continuously stir the solution with the thermometer while it cools. Measure the temperature of the solution as soon as solution becomes cloudy and a solid starts to form. In experiment 2, use the burette to add 0.5 cm cube of distilled water to the mixture in the boiling tube from the previous experiment. Clamp the boiling tube as shown. Gently heat the bottom of the boiling tube while stirring the contents with a thermometer. Stop heating as soon as all the solid has dissolved. Continuously stir the solution with the thermometer while it cools. Measure the temperature of the solution as soon as the solution becomes cloudy and solid starts to form. The same thing we have to repeat 3 times. In the table, they have given the number of times experiment repeated, the amount of or mass of ammonium chloride used, which remains constant in all the experiments, total volume of water used, which changes in each experiment, the temperature change in the thermometer, and the value. So here you can see, we can see the value from this diagram of thermometer and write it down here. We have to write all the points with 1 decimal place. For example, if it is 9.5, it is okay, but if it is 10, so we will write 10.0, which gives us 1 mark for decimal place, for writing all the values in decimal place. We have to draw a graph here where total volume of water in centimeter cube against temperature when a solid starts to form in degrees Celsius. So as the x-axis was drawn, we have to write the scale on y-axis and plot all the points here, and we have to draw a curve. We have to draw a curve here. Also, we have to extrapolate the line. Extrapolate the line on your graph and reduce the temperature when a solid starts to form, when a total volume of 10.5 centimeter cube of water is used. So, we are having 10.5 here. Now, from 10.5, we will draw a straight line till the curve, and then the point where it joins the curve, we have to draw again a horizontal line towards the y-axis. From here, we are going to find out the reading, which comes around 47 degrees Celsius. Solubility in gram per 100 centimeter cube of water is calculated using the equation shown. Solubility is equal to mass of solid dissolved into 100 upon volume of water used. Use this equation to calculate the solubility of ammonium chloride in experiment 1. Now, the mass of ammonium chloride remains the same, which is 5.25 multiplied by 100, and the volume of water used in experiment 1 is 8. After calculating, we get 65.6 gram per 100 centimeter cube of water. Describe how the solubility of ammonium chloride changes as the temperature changes. So, as the temperature increases, solubility of ammonium chloride increases, or you can also write a reverse argument where when temperature decreases, solubility of ammonium chloride decreases. Both will score 1 mark. In this experiment, the volume of water was measured using a burette. Start the advantage of using a burette rather than a measuring cylinder to measure the volume of water. So, as we know that burette is more accurate than a measuring cylinder. State the advantage of using a burette rather than a volumetric pipette to measure the volume of water. Burette can measure variable volumes, or we can write volumetric pipette has a fixed volume. A total volume of 2 centimeter cube of water was added to original 8 centimeter cube of water. Explain the disadvantage of adding 2 centimeter cube of water in 1 centimeter cube portion rather than 0.5 centimeter cube portions. So as we have increased the volume of water by 0.5 centimeter cubes, that is 8, 8.5, 9, 9.5 and 10. Instead of that, if we add 1 centimeter cube difference, that is 8 centimeter cube, 9 centimeter cube and 10 centimeter cube. In this case, it will give us very few points, because of which we cannot draw a proper graph. That will give us a very poor graph and poor results. Suggest why it would not be possible to use 6 centimeter cube of water instead of 8 centimeter cube of water in experiment 1. If we use less amount of water, ammonium chloride will not dissolve. A student tests two solutions, solution C and solution D. Test on solution C. Solution C is aqueous calcium nitrate. Complete the expected observation. The student divides solution C into the portions, 3 portions. The student carries out a flame test on the first portion of solution C. Observation. So using the qualitative analysis chart, you can find out what color calcium is having of its flame test. It gives an orange-red color. To the second portion of the solution C, the student adds aqueous sodium hydroxide dropwise until it is in excess. So observation after adding aqueous sodium hydroxide will give a white precipitate in case of calcium, and when excess of sodium hydroxide is added, the precipitate does not dissolve. To the product from B, the student adds a piece of aluminium foil and warms the mixture gently. Any gas produced is tested. So, as we are having calcium nitrate, so we are having nitrate ions present here. As we will add aluminium foil into this, it will release ammonia, which will show an observation of changing the red litmus paper into blue color. To the third portion of solution C, the student adds about 1 centimeter depth of nitric acid, followed by a few drops of aqueous silver nitrate. So, nitric acid and aqueous silver nitrate test is used for halogens if present. So, as there are no halogen present in calcium nitrate, there is no change. Test on solution D. Use a glass rod to transfer 1 drop of the first portion of solution D onto a piece of universal indicator. The observation given is universal indicator paper turns red. So this is the first observation. As it turns red, it means it is an strong acid. To the second portion of solution D, add solid sodium carbonate. The solid sodium carbonate disappears and there is effervescence. Test any gas produced. The gas turns lime water milky. Now, when carbonate is present, it means always CO2 gas will be liberated. And CO2 gas always turns lime water milky. This is the second observation. To the third portion of solution D, add about 1 centimeter depth of dilute nitric acid followed by a few drops of aqueous silver nitrate. There is no change. To fourth portion of solution D, add about 1 centimeter depth of dilute nitric acid followed by a few drops of aqueous barium nitrate, which gives us a white precipitate. This is the third observation. When barium nitrate is involved, it means sulfate ions are present. Deduce the pH of solution D, which is 1. As we saw, universal indicator turns red in color. We can write pH 1, 2 or 3. Identify the gas made when sodium carbonate is added to solution D. As we saw that effervescence was seen and it is a carbonate. Also, the gas turns lime water milky. It is carbon dioxide gas. Identify the ions in a solution D. So, for the cation, as it was an acid, H plus ions are important ions when an acid is present. And from the last observation of barium nitrate, a white precipitate is formed, because of which we can confirm sulfate ions are present. So it is H plus and SO4 2 minus ions. That is hydrogen sulfate. Next question. Cadmium, cobalt and vanadium are all metals. They react with dilute hydrochloric acid to form hydrogen gas. These reactions are exothermic. Plan an investigation to find the order of reactivity of three metals. Your plan must make it clear how your investigation will be a fair test and how you will use your results to place the metals in order of reactivity. You are provided with powdered sample of each metal, dilute hydrochloric acid, and common laboratory apparatus. In this case, here a clear hint is given that it is an exothermic reaction. Okay, so you can use the method of temperature change here. Also, they have mentioned the acid name, that is, if you cannot remember any other name, you have a hint here, you can use that acid. Okay, you first of all you have to think which apparatus you are going to use. So Here I have selected beaker. Also you can write test tube or any suitable container, for example flask. In a beaker, at 2 grams of cadmium, you have to state the mass of metal used. You have to add 10 centimeter cube of 1 mole per dm cube of hydrochloric acid. So we have to mention the volume and concentration of hydrochloric acid used here. Before the start of reaction, we have to measure the temperature of hydrochloric acid if you are using temperature change method. Once the reaction is complete, again measure the temperature of the reaction. So this will be the final temperature, and when you recorded the temperature will at the start of the reaction, it will be your initial temperature. You have to repeat the same process with other two metals, that is cobalt and vanadium. Now subtract final temperature minus initial temperature. Higher the temperature change, more reactive the metal will be. So this is the conclusion. In the second method, if you are using the gas collection method, so you have to take a flask and in that add 2 grams of the metal. Again, add 10 centimeter cube of 1 mole per dm cube of dilute hydrochloric acid. Also, as we are going to collect the gas, we have to attach a gas syringe to the flask so that the gas can be collected at regular intervals of time. We have to repeat the same with other two metals also. The more amount of gas collected in lesser time is the most reactive metal. So conclusion is important. The apparatus which you are using according to your method, it should match according to the method you are using. For example, here if you are using a gas collection method, a suitable apparatus where collection of gas must be mentioned here. Thank you.